Now, if you're ready to multiply and divide algebraic fractions, then you probably know the basic rules of how to multiply and divide normal fractions in the first place. So a quick revision of that over here. If we had a over b times c over d, nice and simple, it's top times top equals top, bottom times bottom equals bottom. So you can kind of just smush your fractions together. Now you can just do this completely, wait till the end, and then simplify the fraction that you're left with in your answer. Or it's simpler and easier to do some cancelling either vertically or diagonally first. And that helps make sure that the answer that you come up with when you perform that operation is as simple as it can be. And it also stops you from having to work with really big numbers and do really tricky cancelling. When you divide fractions, well, basically you don't do it. You change the division to a multiplication and you flip the second fraction. That's the procedure. Now, the other tip that I'll give you is that if you've got a fraction that's got a couple of terms on the top separated by plus or minus signs there, then you're best off to factorize that expression first. And the reason for that is we know that you cannot take, say, just part of a fraction and cancel it. Here we can see that this is 3/6, isn't it? So it's half. You cannot just cancel part of a fraction with the stuff on the bottom because it just won't work out. We can see that this expression is a half, and yet if I halve this and halve this, now I've got 1 plus 1, I've got 2/3, clearly not the same. So the rule is if you're going to do something to the top of the fraction, you have to do it to the whole top. Now if I'd halved this, and halved this one, and got a half here, now I've got 1 plus a half, that's 1.5. And 1.5 out of 3, it's still a half, so I can do this. But here's the thing, it's much, much easier to factorize first so that you don't accidentally forget a term. And I'm going to use this example to explain what I mean. Now, I'm going to do this with good practice first, and then I'm going to do it with poor practice, and you'll see the potential for a mistake. Okay, good practice is, let's factorize the top here, because we can see that both those terms have the y in common. So now we have a factorized version of our question. Now we're ready to do our cancelling. Now we can see that there isn't any vertical cancelling to do because y and 5x squared and 15x cubed and 2y don't have any factors in common. But we can factor diagonally. So here I can divide top and bottom by y, replacing those with 1, technically is what we're doing when we're cancelling. And I can divide 15 and 5 both by 5. That gives me a 1 and a 3. And I can divide them both by x squared here. So dividing by x squared, that just gives me 1. And dividing this by x squared just gives me x. So I can kind of just cross out the 3. Okay, now tidying up what I've got here, I've got 6x plus 1 over 1. So I don't even really need to write the bottom as a fraction because I've got 1 times 1. And over here, I've just got the 3x over 2. All right, now the way to write this is to remember that we're multiplying this whole thing in brackets by this. So easiest really just to write it down as 3x, 6x plus 1 over 2. And that's nice and simple like that. Okay, now to do the same thing with poor practice and show you the potential for a mistake if you didn't factorize. Now, you'll notice that good cancelling technique, when you divide by something, you replace it with a 1. But we tend to get a bit lazy with our cancelling technique. Now, somebody who says, all right, let's have a look at these. We can divide both of these guys by y, and we can divide this one by y. So we can do some cancelling here by dividing by y. If you were to just cross them out, divide by y, divide by y, divide by y, and not write the little 1s beside them, it would be very easy to make a mistake and then simplify this to say, hey, I've got 6x over 5x squared here. And over here, I'm multiplying by 15x squared over 2. This is a common mistake. Now, what have they done? Well, they've failed to see that this is actually 6x plus 1. And on the next line, this person would be likely to actually cancel their x's here, when you really can't cancel the x's in these two terms because this one doesn't have an x. But they've forgotten about this term altogether. So if you were going to do this method, you just have to be super careful to put 1s down when you do your cancelling. That way you can still do the cancelling the same way as we did before. But writing those ones, it's not so important changing the 5 to a 1, but it's very important changing this y to a 1 because otherwise we might forget that term. Now, if you go to cancel here, you can see that it's tempting to cancel the 2 and the 6, isn't it? So that's another potential for a mistake. But you've got to realise that this term here doesn't have a 6 that you can divide by. So at this point here, you'd say, all right, we've got 6x plus 1 over 1. And just like we did before, you'd finish it off the exact same way. But just be really careful not to cancel part of the top of a fraction or the bottom of a fraction with something. You need to cancel the whole top. And factorising really is the key because it avoids those mistakes. Now we know that it's good to factorise our fractions before we do any cancelling because it's going to avoid any mistakes. But sometimes you get questions where some factorising's been done, but it hasn't been done very well. And this expression here has been factorised, but I can see that it can be factorised further. Now it's tempting to try and refactorise it and leave that 3 there, but that's kind of prone to making a few mistakes. So even though it seems like a lot of writing, it's quicker and easier a lot of the time to refactorise and then multiply. So here I can see that these two have 2 in common. They've also got g squared h in common. And I've got more brackets now. That leaves me with 2g plus 3. Now I've got 2 sets of brackets there. So I've got a little bit of tidying up to do on the next line. Now I'm dividing by a fraction. So while I'm at it, I can multiply and flip. And that gives me g squared h on the bottom. Okay, now at this point, I can be a little bit cheeky and instead of writing the whole thing out, I can see that I've got 3 multiplied by this, which is multiplied by that. So really 3 lots of this part is just 6 lots of it. And I can in fact do this and just turn that into a 6. Now, I've got a whiteboard marker here. How would you have done it in your book? Well, to save yourself from writing out that whole line again, you could literally just go cross that out and put a 6 there. Or you can rewrite it again if you preferred it to be all tidy. But now I've got 6g squared h outside of 2g plus 3. I don't need that other set of brackets. And now I can start doing some cancelling. I can see straight away that the g squared is going to cancel and the h is going to cancel. And here I've got 5 and 10. I can divide both of them by 5. That leaves me just with j squared, and up here I've got 2. And also j squared and j, I can cross out this j entirely and change this j squared to just j. So that's left me with, let's just sort of tidy it up. We've got the 6. We've got 2g plus 3. And the whole thing here is over j multiplied by, and here I'm really just left with 2. So now the final step is I can just multiply this 2 by the 6 here, and that leaves me with one neat expression, 12 2g plus 3 over j. And there's no more cancelling that needs to be done. You could expand those brackets if you want to, but there's no real need. It's 6 of one, half a dozen of the other to decide what's neater.